All right, students, this is lesson 732. In this lesson, we are going to learn, actually 733, sorry about that. We're going to learn how to do this one, solving systems of equation using the elimination method. We're going to start on page 14, so go ahead and find page 14. It looks like this one here. And go down to develop and understand A. It says, consider this system. You should be able to solve it by simply adding the equation to eliminate y. Try it. What is the solution? So all they're saying is, go ahead and add up these equations. And when you do that, if you're adding equal things to equal things, you're still going to be equal. So 9 plus 3 is 12x. Negative 2y plus 2y is 0y. I'm not even going to write that down because 0 times y is 0. And notice we've eliminated the y. And so we'll get 12 times x is equal to 12. Well, obviously x is 1 because 12 times 1 is 12. So we know x is 1. We still need to know what y is. But looking at one of these equations, we know that 3 times x plus 2 times y is equal to 9. And now knowing that x is 1, I can substitute 1 for x. And I get this, and so 3 plus 2y is equal to 9. Subtracting 3 from both sides, I get 2y is equal to 6. And 2 times 3 is 6, so we know that y is 3. Now the last check would be to make sure that it also works in the other equation. 2x minus 2 times y is equal to 3. I think x is 1, so I'm going to do 9 times 1. I think y is 3, so I'm going to do minus 2 times 3, and hope that equals 3. And we get 9 minus 6, which equals 3. So that checks out. So the method we just used is called elimination because notice when we added those two together, we could eliminate that variable. Okay, you can also eliminate by subtracting the equations. One thing you'll notice here is that these equations are written in standard form, and that makes this elimination process a little bit easier. So let's do this problem and see how it works for this one. It says a corner store is having a sale on flip-flops and sunscreen. 2 bottles of sunscreen and 1 pair of flip-flops cost $16, while 3 bottles of sunscreen and 2 pair of flip-flops costs $28. From this information, can you determine the cost of 1 bottle of sunscreen or 1 pair of flip-flops? And it turns out we can. And we're going to use elimination to do that. First, we need a system of equations. Let's let x be the cost of flip-flops and y be the cost of sunscreen. And so 2 bottles of sunscreen and 1 pair of flip-flops. Oops, I said that wrong. Let's move these variables around. Let's let y be the cost of flip-flops and x be sunscreen. And then we get 2 bottles of sunscreen, so 2x, plus 1 pair of flip-flops, 1y, is equal to $16. And we also know that if we buy 3 bottles of sunscreen, plus 2 pairs of flip-flops, it's going to cost us $28. All right, so we want to solve this set of equations. And to do that, we are going to think about this. So if 2 pairs of flip-flops, or 2 bottles of sunscreen, 1 pair of flip-flops, 16. What if we just doubled that? So let's buy 4 sunscreen and 2 flip-flops. That would double the price, obviously, so that would be $32. Well, now, notice we have the exact same number of flip-flops in both these. So if I subtract what I purchased, if I subtract the price of the flip-flops away from there, I'll be left with the remaining. And if I subtract 3 bottles of sunscreen from 4 bottles of sunscreen, I get 1 bottle of sunscreen. And if I subtract the prices, I get 32 minus 28 is 4, which means 1 bottle of sunscreen must be $4. And then I can just use one of my equations like 2x, 2 bottles of sunscreen plus 1 pair of flip-flops is equal to 16. So And I now know that sunscreen is $4 a bottle, so 2 times 4. Plus my flip-flops has to equal $16, so 8 plus a pair of flip-flops is $16. And that would mean that the flip-flops must be $8. Okay, so sunscreen, $4 a bottle, and flip-flops are $8. All right. We might want to check that in this original equation. Also, make sure it's true that 3 bottles of sunscreen plus 2 pair of flip-flops at $8 each is equal to $28, and that's 12 plus 16, and that's 28. So it does work. All right. We're going to try one more problem here. On the next page, here's another example of a problem you could solve by elimination. It says that 7 times x minus 4 times y is 100, and 3 times x minus 2 times y is 40. Right now, if we added those 2 equations together, and don't do this, I'm just demonstrating, we would get 10x minus 6y is equal to 140. That doesn't help us because we haven't eliminated a variable. So what we need are the coefficients to be opposite to add them together, or the same to subtract them to eliminate a variable. And we could get this coefficient right here to be positive 4 if it was multiplied by negative 2. And if we multiply both sides of an equation by the same number, it will still be equivalent. So that's what we're doing right here. Notice we multiplied both sides of this equation right here by negative 2. And when we do that, we are going to get negative 6x. And negative 2 times negative 2y is plus 4y. And negative 2 times 40 is negative 80. Now adding these 2 equations together, 7x plus negative 6x is 1x. And negative 4y plus 4y is 0y. So we just get x equals negative 80. Oh, we forgot to add these together. Sorry, it shouldn't be negative 80. X equals 100 plus negative 80, which is 20. So x is 20. Okay, now we're going to substitute that 20 in for x here and simplify that to 140. Subtract 140 from both sides. And we get negative 4y equals negative 40. Divide both sides by negative 4. And we get y equals 10. All right, and then we want to check that by making sure that those answers, y is 10 and x is 20, works in the other equation. That's 60 minus 20, which is 40, which means that's true. So that is the solution. All right, we have a little time, so I think I'm going to go ahead and show you how to do one more problem. And we're going to go to this page. There's a bonus problem I want to show you how to do. It's right there. We're at page 19. All right, now this one, we want to solve this by elimination. But notice this is 3 and this is 2. So the number that you would have to multiply by one of these so you get either you want to get the same number so that you can subtract them, or opposite numbers so you can add them. And it's generally easier to add for students. We'd have to multiply by a decimal number to make that happen there. But there's one thing I could do here. Let's say I were to multiply this equation by 3, and this equation by negative 2. Now, watch what happens. So the top equation becomes 6x minus 9y equals 36. And the bottom equation becomes negative 6x minus 8y equals negative 30. So notice what happened. I ended up with coefficients that are opposite. So now I can add those together. negative 9 plus negative 8 is negative 17y. And then negative 36 plus negative 30 is positive 6. And so now I'm going to divide both sides by negative 17. And this is I'm going to leave this as a fraction because as a decimal it becomes quite an ugly decimal. But I'm going to tell you right now that y is negative 16. You just have to go back and figure out what x is by plugging y into one of the two original equations. So put negative 6/17 there for y and figure out what x is. All right, that's the end of the video. Go ahead and try a couple of those problems, and we'll talk about this next time we meet in class.